Welcome to the lesson Confidence Intervals for One Population Mean. Statistical Inference. Statistical inference provides methods for drawing conclusions about a population from sample data. You know, parameters are unknown. So, we try to obtain information about the population parameter. What are the population parameters? You already know population mean. Population mean is a population parameter. So, sigma, which is population standard deviation, and population proportion, etc. A common problem in statistics is to obtain information about the population mean mu. Let me consider people in the world. How do we find the average weight of people? It is impossible to measure weight of each person. So, what do we do in statistics? We take a sample. We make a sample, maybe 50 people, or maybe 10,000 people, maybe 1500 people. However, we can measure their weight and find the average weight of the sample. We think it is pretty good representation of the population mean, but clearly it is not totally exact. There are several reasons, but I can give one reason. We take a small sample, but population is very big. So here we are going to find a range for the population mean. So that is the confidence interval. We find the lower bound and upper bound for the population mean. Let me give you some examples. The mean cost of wedding in 2014. The mean starting salary of statisticians. The mean height of Stat 2210 class students. The mean income of family of a small neighborhood. If the population is small, we can determine mu exactly by first taking a census and then computing mean from the population data. Think about last two examples, stat class and neighborhood. So, how many students you have in your stat class? Maybe 30, maybe 50. But you can measure their height of everybody. So you can use the whole population for your experiment. Then you can get the exact height. Similarly, a small neighborhood, think about 50 families. So we can collect their income and find the exact value. But think about first two examples, cost of wedding and salary of statistician. It is very big population. If the population is large, taking a census is impractical, extremely expensive or impossible. We can usually obtain sufficiently accurate information about mu by taking a sample from the population. Statistical inference. Two types of inference methods. First one is estimation methods. Under this, we are going to talk about point estimates and confidence intervals. In this video, I am going to talk about estimation methods. But next, hypothesis testing. In my next video, I will be talking about hypothesis testing. Point estimates. Read the problem. A simple random sample of 36 new mobile homes prices are given. So they are asking, you see the last sentence, use the data to estimate the population mean price mu of all new mobile homes. So this is the sample. So then how do we find or how do we estimate the population mean? We estimate the x bar. Estimate of the population mean is x bar. So you know how to find the x bar. Add all values together and divide up by number of values, which is 36. Then answer is 63.214. An estimate of this kind is called a point estimate. Why do we say point estimate? Because it consists of a single number, just a point. Therefore, we call it is a point estimate. Now, confidence intervals. Simple conditions for inference about the mean. We assume these assumptions. We have a simple random sample. Second one, the variable we measure has an exactly normal distribution. It means our data set is coming from a normal distribution. And the last assumptions, we don't know the population mean mu, but we do know the population standard deviation sigma. In short, mean is unknown, sigma or standard deviation is known. A level C confidence interval for a parameter has two parts. An interval calculated from the data, which has the form estimate plus or minus margin of error. This means we need to find the estimate the parameter that we are looking for and then find the margin of error. So then we subtract margin of error from estimate to find the lower limit, and we add margin of error to estimate to find the upper limit. A confidence level C, which gives the probability that the interval will capture the true parameter value in repeated samples. So let me explain this using this graph. 95 confidence level and 0.6 margin of error. So what is the meaning of 95% confidence level? What we do, we take several samples. It means we take one sample and n equal 498, then find the x bar, then x bar plus or minus margin of error, which is 0.6, we calculate the interval. That is the confidence interval for the first sample. We take another sample, the same sample size. Again we find the x bar of that sample, in here 28. Then 28 plus or minus 0.6. Then you can have the confidence interval for that sample. Similarly, we take several samples, simple random samples, many simple random samples, and then we have a confidence interval for each simple random samples. So then 95% confidence level means 95% of these intervals capture the unknown mean of the population. Think this way. If you had 100 samples, then 95 intervals out of 100. 95 intervals out of 100 capture the unknown mean. So that is the meaning of 95% confidence level. How about a 90%? 90% confidence level mean then not only 90% of these intervals capture the mean. So, confidence intervals for a population mean. As I mentioned before, how do we find the confidence interval? Estimate plus or minus margin of error. So, what is the estimate of the population mean? It is x bar. So, we need to find the x bar. Then, what is the margin of error? Yes, margin of error is z star sigma over root 10. You already know sigma, which is standard deviation. Population is standard deviation. You know we assume sigma is known at the beginning of this chapter. Then n is the sample size. What is the z star? It is the critical value. Okay, how do we find the critical value? I will explain in a few minutes. Yes, this is the confidence interval. You see we have a middle point, lower bound and upper bound. So, middle point is the x bar. Middle point is the sample average, sample mean. Then, you can get the lower limit x bar minus z star sigma over root 10 and upper bound x bar plus z star sigma over root 10. So what is the distance between x bar and x bar plus z star sigma over root 10? It means middle point and upper bound. That is the margin of error. Or you can say maximum error. Similarly, here too. So again, this is the margin of error or maximum error. Or this is the margin of error or maximum error. How to find the critical value z star? Let me explain this using this 95%. When confidence level we use C as a notation is 95%. It means this is the standard normal curve. You already know that. 0.95. It means probability equal 0.95. The area, white color area under the curve has the 0.95. If it is 0.95, what can you tell about the corners, blue color area? Yes, those must be 0.025 each. Why? Total area is 1. So, now how do we find the z star? Yes, go to table and check the number in the middle of the table. Check the number 0.0250. Then you will get z star equal negative 1.96. So we discussed how to use the z table under chapter 3. Actually here we find the z star corresponding to the area at the left corner. Here area 0.025. So again check the number 0.0250 in the middle of the table and find the location or find the z value corresponding to 0.025. These are some examples. These are not the only numbers. You can use 80%, 85%, 82%, any number. But these are the mainly we use. Confidence level 90%, critical value is 1.645. Similarly, you see 95%, 99%. Let me give you some examples. 90% confidence interval for mu. Yes, how do we find it? Z star for this one should be 1.645. Therefore, you can find the confidence interval for 90% x bar plus or minus 1.645 times sigma over root 10. Similarly, 95%. What do you think? You already know that x bar plus or minus 1.960 times sigma over root 10. Then what is the 99%? Then you know z star is 2.576. Therefore, you can find the confidence interval using this equation. How confidence intervals behave? We would like high confidence and a small margin of error. Yes, think about your test. If you have high confidence for the test, you will be happy. So same thing here. High confidence suggests our method almost always gives correct answers. And a small margin of error suggests we have pinned down the parameter precisely. So, our next question, if we need a small margin of error, how do we make this small? Right, z star gets smaller. Yes, you see that. What is the margin of error? Margin of error is z star sigma over root 10. If z star is a small number, then whole thing will be small. Right? Or other word, you can say lower confidence level. Lower confidence level. So next one is sigma is smaller. Yes, sigma is known. Therefore, we cannot change sigma. It gets larger, you can get a smaller margin of error. Now next, how do we find the sample size? Right, n equal z star sigma over me. So this is the power, second power. This is the sample size. So you know z star, you know how to find the z star corresponding to C, confidence level. And you know sigma is known. So you know margin of error, it should be given. Therefore, if we know all the values here, so we can find the n. But make sure you round it up to nearest whole number.